This is Dr. Carroll, and this is part 2 of primitive wrapper classes in Java. So the part 2 talked about setting up what they are, and now in part 2 I'm going to give some examples and talk more about the different members, both fields and methods. So let's jump into that. So the primitive wrapper classes have some fields that are very helpful. And so, for example, if we want to know what the smallest possible integer value is in Java, we can just call integer.min_value. And so that is a field, so we don't have to have an instance of it to be able to access it, and it's static, it's independent of the any instantiation. So and that's why we call it integer and not our int object or some reference name. We use the class name .min value to access it. And similarly, there's also integer max value, which is the largest possible value. There's the double, float, long, all have fields with the same name and interpretation as well. So that's primitive wrapper class fields. Let's talk about methods now. So for example, let's look at the static methods in the character class, in the character primitive wrapper class. And so we have all of these static methods so that we can call to help us out, to determine if it's lowercase, if it's uppercase, is it a white space, etc., so that we don't have to have long if statements to determine that. So let's look at an example here. And so if we had a character object called ch, and we can use shorthand again, just give it the character. We use characters by a single tick, and we can assign that. What we don't do is we don't call it as an instance method. This would be calling it as an instance method, so this is not allowed, it won't compile. And so instead what we would do is we would use the name of the class, because it's a static method with the member operator is lowercase, and then we would pass the char to it, and this would return false, and it'd display false here. And so I just wanted to point that out. This is how I would have thought of it initially if I was learning about these for the first time, but they're static methods, so we call the class name and access that. Static is independent of any instance of that. Now let's talk about comparing values with reference objects here. So for objects, what is stored on the stack? It's the memory location for that object. We call that a reference. Okay? And so let's look at what happens in this example here. We have two integer references, one called solution, one called response. And we're using the shorthand notation of just assigning integer to them, and they have the exact same value, and we could display that. And so then we have this if statement: if the solution equals response, then let's display the solution and response are the same. And then we have an else condition as well that says the solution and response are different. And if you run this, it will display every time that solution and response are different, because on the stack they are referencing two different objects that each have a value of 128, but the value on the stack is the memory location. But there's two memory locations, and therefore the two different memory locations are not equal. And so when we do equality, it's looking on the stack at what is the value there. And so, and to make these print statements more complete, maybe we could have tacked on objects there. Solution and response are the same object, or solution and response are different objects, and that would make it more clear of what's going on. And so equals test to see if the value on the stack is the same, or in this case with two objects, if they're referencing the same memory location. As an aside, Java does some interning which causes a little bit different results if you use smaller values, but that's an aside. So instead of equals equals, to compare objects, we have two options. We can use dot equals, and by dot equals I mean call that on an instance of it. It's an instance method, and pass it some other object. Or we can use compare to, again an instance method, and pass it another object. With dot equals, it's going to return true if the values are the same and false otherwise. And so if we don't really care if they're the same object, then we want to actually call dot equals instead. And so whereas if we're trying to compare them and we actually want to get a relative ordering, then we would do compare to, and which is standard to return one of three values. It's going to return 0 if they're the same. It's going to return less than 0 if the object that we're calling, so whatever is left of the member operator, the period, is less than the object, or the only other case available is it'll return something greater than 0 if what the object we're calling it on has an instance data value that is greater than the other object's instance value. Let's see what this would look like in code. We wanted to say, hey, are they the same? We would say solution, potentially, or we could have changed it to response. But solution equals, and we're calling equals on solution. So if you want to picture this, picture that circle. Solution is that object, and one of its methods is equals. And so it's calling it on that, so it has access to solutions data instance. And then we're calling it with response, and so then we can get responses data values from it. And so that will determine if it's the same. If the values are the same is what it's getting there. And we could have changed it to response.equals and pass in solution. That would have worked just as well. Okay. Now, or alternatively, we could have done a compare to and said, hey, solution, look at your instance data and compare it to the instance data of response. Is that less than 0? So then it's less than, or is it greater than it? So that means solution's value is greater than the response's value. Or our last condition, which the only thing left is that they are equal, that the values are the same. And so those are the two ways we do comparison with objects, and in particular with primitive class wrappers. Okay, so now let's move on to the next part. So if we wanted to convert to or from string objects, which is a common thing, so let's start with converting to a string. So there are two different ways we can do this. There's both an instance method and a static method, and it depends on, do you already have an instance of one of the primitive wrapper classes or not? So let's look at each one of these. So the instance method is .toString. And so this is a class member that returns a string representation of the object, so you can think the instance variables. And so if we already have an integer object or we already have a double object, we call toString on that to get a string version of it. Alternatively, if we don't want to call new or create a new one, we can just use the static method, which means we need to use the class name and the member operator to call it, and then just pass it that. So double has a toString, character, boolean, long, all of them have this toString method that we can pass it in, or we can use the instance data version. So let's look at some examples. So if we, again, are using solution equals 128 and we wanted to have a string method, what we cannot do is just say message equals solution. That does not work. Java doesn't support that, and it's going to say error, incompatible types, integer cannot be converted to string. We need to manually do that. And so the way we do that is message equals solution dot toString. That will produce a string, return a string, then we can display that string. In this case, it would display 128. Now, just to show it a little differently. Using the static method, we could say, hey, I need a string version of 7. And so we can call integer.toString and pass it to 7. And notice this doesn't deal with our solution reference. It's independent of that, and that would display 7. So that's converting to strings. Now let's talk about converting from strings, which to me is a little bit more complex. And so we again have two options, but they're kind of different. So we have integer.parseInt, so it's a static method, and we provide it some string. And so it's a static class member, and it's going to return an int. And you can remember that because it says parseInt. The other one is also a static class member, but it's a value of. And so this one returns an integer object. So if you know that you want an integer object, then use value of. If you're actually really just trying to get an int, well, then use parseInt to be able to get that. So let's see some examples of that. We could have integer.parseInt and the string 2019, or we could do value of. And so the parseInt is going to return 2019 as an int, whereas the other one's going to return an integer object that is storing 2019. And as a side, as a little bonus, there's another method in the integer class, and it is toBinary string. So this is kind of cool. So if we, for example, passed it -1,000,000, and notice you can use underscores to make million a little bit more readable, that will go ahead and return a string, which is the binary representation for that number. I think that's pretty cool because it saves you time having to do that, and you could be able to display the binary version of any integer easily in Java. That's this video. I hope you enjoyed it.